Oh, why, hello there. Didn't see you there. Hi. Well, since you're here, let's do some torque problems, shall we? So, torque is um, denoted with ooh, that's the highlighter. Oh my goodness, starting off things a little crazy. Torque is denoted with a capital Tau, T-A-O, T-A-U. Whoops, Greek, not my first language. Okay, getting tired of quarantine, yo. All right, so this is the angular equivalent of force. It's analogous to force, which is sort of like the translational equivalent. So basically, torque can cause or is required to in order to experience a alpha. A rotational acceleration requires a rotational force, what we call a torque. And in order for that torque to exist, three things have to happen. You need to have some translational force. So there has to be some push or a pull. And that push or a pull has to be some distance away from the point of rotation, the pivot point, if you will. So imagine, for example, that you wanted to get a door to open, right? To rotate open. Well, in order to get it to rotate open, the first thing you'd have to do is be able to push on it, right? So that's the force component of this. The second thing that you'd have to do is you'd have to push somewhere on the door that is not the pivot point itself. If you push directly on the door hinge, the door will never open, right? The torque is only applied when you're some distance away from the point that is rotating. And then lastly, it needs to have some uh, angle between these two things that is not 0 or 180 degrees. In other words, there has to be some component of that force that is perpendicular to the moment arm or the radius of that circle, if you will. In other words, like if you tried, say, pushing a door open on the very outer edge of the door, farthest away from the hinges, but you pushed the door directly into the hinges. So, like parallel to the plane of the door wouldn't open, it wouldn't close, it wouldn't do anything because you're just compressing it, right? You're not pushing it in a swingy way. In other words, there's no tangential component of your force to the door's rotation. So, of course, it won't have a tangential acceleration and it won't swing open. The other way that we could write this, the vector notation for this would be F cross R, where force cross R, that's not a multiplication symbol, it's a cross product. And cross product is very similar to dot product. Dot product was, remember, cosine theta of the angle between the two vectors. Cross product is sine theta of the angle between the two vectors. So each of these two statements are equivalent statements. Cross product is just that sine theta. So going back to this question, we have a Fisher person, and that Fisher person is basically going to be defining the pivot point. So this fishing pole is rotating around that pivot point. And the fishing pole is approximately straight line. And then there's a fish that is exerting a non-zero force on the fishing pole. So what we're looking for here is the magnitude of that force, which is given in the problem. We're looking for the distance between that force and the pivot point. That would be equivalent to L. And we're looking for the angle between those two things. And that would be defined by this angle here. So this is going to be my theta, which in this case is going to be 20 plus 37 degrees. And from that point on, it's just plugging in and solving out, right? My F is given. F is given. Also given is R. R is equal to L in this case. And then theta is given. So this is a plug and chug, solve it out type question. Boink, 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 boink. And then the second part, because these are vector quantities, right? What is the direction of that vector? Well, relative to the frame of reference of the picture that they've given, this force would cause my fishing pole to rotate clockwise. Yeah, so there you go. Now, the fisher person pulls the rod back. So what that does is it increases the angle it makes with the horizontal to 43 degrees. Right? In other words, in my second circumstance, um, let's draw this out. I'm going to have the same pivot point, but now this angle here up between the pole and the horizontal is now 43 degrees. Right? Now, the fish applies the same force in the same direction. Suppose that still means 37 degrees below the horizontal. And so what's the uh, increase in torque? Note that it doesn't say what is the new torque, it says what is the increase in torque. So here, now we have an angle here. This angle is now closer to 90 degrees, right? This force is now closer to perpendicular. And for that reason, because theta has increased closer to 90, sine theta has also increased. Now it's closer to 1. Therefore, the torque has increased. Now, to actually find that increase, you just plug the numbers back into the equation and solve for it again. So I'm not going to go through that part, but this is a great type of question for this year's AP exam, right? What would happen? What would the outcome be if the following change occurred, right? And provide an explanation for that. So in my response here, my explanation, I don't actually do any math at all. The picture is not really necessary here. But I'm able to justify the fact that this torque has increased because I'm able to justify that the angle and therefore sine has increased. I've already related that sine theta as being proportional to torque. And so you can see that there would be an increase in torque there as well. For the second question here, again, everybody's going to have a different value for A and B in terms of these lengths, but the equivalent forces. So here, it's very important to note that we've defined the positive direction as counterclockwise. Counterclockwise. And so what that means is positive torques will be defined by the 12 Newton force, and negative torques will be defined by the 10 Newton force and the 9 Newton force. In other words, these two forces are causing my wheel to turn clockwise, which is the negative direction. And this force is causing my wheel to turn counterclockwise, which is the positive direction. Okay, and we're asked for the net torque. Well, net means sum of all, so that would be torque 1 plus torque 2 plus torque 3, right? And let's label this as number 1, number 2, and number 3. Now, because of the directionality here, my T1 is going to be positive. So the net torque will be torque 1, and that's positive. We're going to subtract torque 2 plus torque 3. And again, those torques can be calculated as RF sine theta, where theta is the angle between R and F. In this case, theta is 90 degrees for all. So we would have the net torque be R1 F1 minus R2 F2 plus R3 F3. And that would be my solution, just plug and chug in there. And that's it. Torque. Pretty straightforward stuff, my friends. Pretty straightforward stuff.